So good morning, one and all. So welcome back to today's class on tribology, right? So before going to the remaining part of about our wear in module 2, since our internals is approaching, I just wanted to discuss a case study which will be there in the question paper pattern, right? So the pattern is as usual, you will be having theoretical questions as well as one case study and one innovative question. I have shared this case study already in the Google Classroom. I just wanted to brief out like related to what it is. Okay. So the case study is visible, na Chaitanya?
Yes, ma'am.
Yeah. So you have to study about this case study, which is on tribology in industry. It is an journal paper which is published in 2015. So they are here focusing on the concepts of friction and wear, how it is coming related to two case studies. Okay, so you can see that the wear and the degradation mechanism, which comes across two principal vehicle tribo systems, are presented here. So it will tell you what is the main causes for their premature failure. So it is mainly due to wear, friction and other mechanism which gets degraded due to this wear and friction. So here they have just made an in-depth analysis with respect to two case studies. So the first case study here concerns mainly about the malfunctioning which takes place in an automotive cast iron pressure plate. Okay, so this pressure plate is operated across our automobile clutch system. So mainly you're referring this automotive cast iron pressure plate for an automobile application. So where you come across near the clutch system in any transportation vehicle. So the second case study here they have dealt is mainly related to the unexpected failure which come across the brake disc. So here the brake disc what they have analyzed is of stainless steel. So they have analyzed how an unexpected failure means a sudden failure which come across in any stainless steel, in any type of brake disc. But here it is related to stainless steel type. They are focusing on a motorcycle. Okay, so these are the two case studies what they are dealing here. And again, it plays a vital role related to the design aspects. So both the components are designed basically such that it can function under sliding motion. So when sliding motion come across, you know that the friction comes into picture. We have dealt the theoretical aspect of friction and little amount of wear already. So it is associated with the same concepts. So when it is sliding across continuously when the vehicle is on, so the friction conditions will lead to cause some amount of wear in the consumable part of non-metallic parts, right? So these are focused to be as our tribo system. So analysis is done with respect to the clutch disc and the brake pad, both of it. So in both the cases, after the analysis, they found that the unexpected failure which come across in any brake disc is due to the conjugate metallic parts. So what happens related to conjugate metallic parts is the system damage come across all of a sudden. So due to the termination of the system damage, it results in unexpected failure. So they tested this by an experimental approach. So this experimental approach helped to identify what is the main root cause for the failure. So that you will come to know when you do the characterization at the microstructure level. Okay, I told you the deformation, the wear which come across is either at the microscopic or at the macroscopic level. When it is at microscopic level, you have to go for the structural characterization either through TEM, FESEM, SEM, whatever, which provides you the morphology related to the microstructure of a particular characterization. So along with that, they have also made the observations related to the metallic contact surface. Only the microstructure will not yield you to know exactly why the unexpected failure is. Because when the two mechanical components are sliding, the contact surface will be subjected to a high amount of load and pressure, which is the main cause for either the friction or the wear. So even the observation related to the metallic contact surface is very essential. So this observation where it yields to either wear or friction was observed by using optical and scanning electron microscopy. So scanning electron microscopy is nothing but what I told you already, SEM. Okay, so optical microscopy also we have, such as FTIR, one of the most commonly used optical instrument. So along with that, they also measured some topography measurements. One of it is the hardness level. Since we are dealing with respect to microstructure characterization, even the hardness is measured across the micro level, and hence it is called as micro hardness, and surface topography is measured. So surface topography again helps you to understand what is the level of asperities which are there across the contacting surface. So if one is made up of an hard material, another one is of soft material, then the asperities from the hard material move on to the soft material by means of plowing, where deformation theory comes into picture. If it is made up of same material, then the plowing concept will not come into. So they will show about the adhesion property in that, and also the level of lubrication film which is adhering in between the two contacting surfaces. So all these things will be analyzed using our surface topography measurement. Okay, so for the case, they used the stainless steel type of brake disc in particular. Okay, so they also made a simulation using finite element analysis, which is employed in any tribo system. So this entire case study is really a beautiful one, which clearly opens in practical how the wear and friction which is coming across in any tribo system could be identified, and how you can identify the failure mechanism through some standard hypothesis which has to be validated for the initiation of wear or friction in any mechanical component. So this is about the entire overview of the paper. What I have told you, it is totally related to the concepts what you have understood. So this will provide you an practicality in how important the subject tribo is related to failure as related to friction as well as the wear compared to any one of the application. So here we are focusing on automobile application. It could be a four-wheeler or a two-wheeler where you have two case studies. So you can go ahead with this later. I have told you the entire description. So in the introduction and the background, they have provided the concept of what is the work done until now related to the analysis of the failure in the four-wheelers as well as the motorcycles. So this provides you the entire literature survey related to the work done until now by various people. Okay, so based on that, they have identified some of the research gaps in which the work has to be carried out, and hence the last paragraph will provide you the objective of the material, what they are doing. Until here it is the literature survey. Okay, so what they are doing is been listed out over here. And finally, based on the objective, they have formulated the experimental techniques. So what they are using, which equipments they are using. So all the equipments which are used to check the micro hardness to that of micro characterization, everything is been mentioned over here. So they are using SEM, and they are using electrodispersive X-ray spectrometer, which is EDS. Okay, EDS is always associated with the SEM. Okay, SEM with EDS will provide you the beautiful microstructural analysis. So that has been carried out, and also they are using mechanical Taylor-Hibberson stylus profilometer, which helps in yielding out the micro hardness level of it. Okay, and also the failure analysis is been identified by using SEM. So FEI, this one will provide you the specification detail of the equipment what they have used. So this is the experimental techniques what they are using. So based on that, I told that we have two case studies. So the first case study is dealt with the clutch disc tribo system. So where exactly the failure come across, you will analyze, and then they are getting the characteristics here of the pressure plate by means of SEM morphology. Means you are taking the microstructure of the pressure plate, right? So you can see the variations across the contact surface. So this is a sliding direction in which the material is sliding. So across the contact, how the surface of the pressure plate is. Okay, so now how the groove is being formed due to continuous sliding due to wear, and how the oxidation is coming into picture due to the atmospheric uh, effects. So all these are provided in depth, and also when continuous sliding, they have taken even the morphology where the wear has come across. So you can see the variation in the microstructure at the wear part, and similarly they have used the optical micrographs. So these are the optical micrographs which shows you the variation in the pressure plate. So this is at 250 microns and this is at 50 micrometer. So this provides you the scars which are all formed, which are nothing but the asperities across the surface where it is in contact, due to which the wear arises. Okay, so please go through the entire paper in depth, and some questions will be asked related to the case study. It is not like the entire paper will be shooted out with a single question. To answer the question related to the case study with the concept of wear and friction, you should be knowing what is the whole and soul of this paper. So if you understand this concept, you will be able to answer the question related to the case study. So first case study is related to our pressure plate. Okay, so the second case study, what I told, is related to our brake disc or the brake pad in a tribo system. So here also they have analyzed the entire brake system with respect to the morphology across the crack, how the surface looks like, and what is the level of oxidation which is happening on the surface. Okay, all these, and this is the sliding direction in which the material is sliding, due to which the crack which has been generated due to the wear, everything has been shown here, and this material is again responding to the external stimuli of atmosphere, and hence the oxidation marks are also being shown. And what they were studying was with respect to the brake plate of brake disc made up of stainless steel material, and hence they have checked the hardness level and the tempered structure across the contact area. Okay, so B is the initial structure of the bridge area, and this one, and A is the hardness and tempered structure of the flange area. So this flange area will show you the variation which is coming across due to wear. So please go through it, entire analysis. You will really understand how good the concept of wear and friction is, how it could be analyzed, right? So total information you will be getting on. And they have done some numerical simulation using finite element analysis for both the case studies. Okay, so here the von Moy's stress concept is also being used, what we have studied already, right, related to our Mohr circle. So all these concepts are there in actual how in industry they make the use of tribology system to overcome a wear and tear in any mechanical components which are revolving, which are rolling, sliding against each other. And they have beautifully posted out some conclusions related to both the case studies. So they have checked the experimental studies with that of FEA results, and it was almost matching, but not exactly into, but shows that the results what they have yielded is matching with that of the theoretical aspect. And hence it is a good paper. Please everyone go through it. I have shared this already in the Google Classroom. Okay, so this is about our case study question for our first IA. And apart from that, one more thing I have to tell you is about the innovative question. So how the question will be related to the innovative point of view. Right, so basically what I just want you to suggest in which area you have to think about for innovative is, suppose you know the entire concept of tribology, you are aware with wear, you are aware with friction, you are aware with lubrication, bearings, all things. Only thing you are clubbing the concept of everything into a beautiful subject of tribology to analyze how to overcome this friction wear analysis part, right? So when you know all the concept together as a whole, it is not a new subject to you. In the area, what you have to think is, suppose if you are an professional tribologist, how you will design and develop two mechanical components so that you can reduce the amount of friction as well as wear to almost equal to zero. Yeah, negligible. I cannot say that it is zero, at least to the minimum extent where the efficiency will improve and you can enhance the reliability of any mechanical component which is either sliding or rolling. So this will be the key area on which the innovative question will be given. So now you have to think on your own perspective. If you are a tribologist, how you think about all these aspects. I'll just give you a few guidelines. If you want to design two mechanical components with respect to tribology aspect, you have to right away dig from the materials. First, you have to select the material which is not being affected badly by the external and environmental condition, and also temperature plays a vital role. Even the size, the dimension and the geometry of the mechanical components what you're designing also plays a vital role. Along with that, the type of lubricant film you're using, and whether it is having an adhesive layer, whether the two materials what you're selecting for the mechanical component have the capability of adhesion or whether they don't adhere to each other. That also depends upon the enhancement of your coefficient of friction or the wear terminologies. Again, one more thing in which it affects is depending upon the material, whether both the mechanical components are made up of same material. Like if you say if one is hard, the other mechanical component is also an hard material, right? So if you use both of the say components made up of hard material, then the amount of friction what you're getting will be little bit reduced, provided you're using a good layer of lubrication film. Suppose if you're using one soft material and one hard material, always you remember that along with the friction wear comes into picture, because here the flowing comes into the asperities from hard material flow into the soft material. It results in the phenomena of junction growth. So all these concepts we have studied already, including in our module 1 and module 2 to half part of it. So please keep all these things in mind and answer how well you can design a component with reduced amount of wear and friction. So this will be the area on which you have to work in for innovative question. So any doubts related to the case study and the innovative question? Is it clear? Hello? Hello? Kindly respond. Yeah, so this will be the two questions what you have to prepare by yourself, and the remaining portion it will be there until what I covered today. So first module we have completed and second module we are half the way. Friction is completed. We are focusing on wear. So related to wear we have studied the concept of wear, right? How it comes into, we have to understand some mechanism and classification of wear. So that I'll be doing today right away. So with this, I will stop presenting the case study and we will move on to the wear concept. Just give me 2 seconds, I will share it. Is the slide visible, guys?
Yes, ma'am.
Yeah, fine. So in the last class, after dealing with the effect of coefficient of friction related to the metal and non-metallic materials, we started digging up related to the concept exactly what is wear exactly, right? And where and all the wear comes into picture. We just dealt about what is the main reason for the occurrence also we dealt, and we were supposed to now start with the different stages of wear. So I told you in the last class mainly the stages of wear is related to three. One is the primary, the secondary, and the tertiary stage. Okay, so the primary stage is nothing but called as an early run in period. So what do you mean by that? This is the initial stage in which the wear starts up, right? So this is the early run in period. So here you can observe that the surfaces adapt to each other and the wear rate might vary between high and low. So this is the initiation of the formation of the wear. So where it can vary, it will be fluctuating. The amount of wear it come across between the two, across the contact area between the two mechanical components, which will be fluctuating high and low. Means you can say that it is an early stage where the wear amount is not stabilized yet. Okay, so the uniform amount of material is not weared out. So it has a fluctuation. Sometimes it could be high and sometimes it could be low. If that is the condition, you have to understand this is now the stepping stage for the cause of the wear between the two mechanical components. So this is called as our primary stage. And next comes is about our secondary stage. So here the amount of wear which is coming in across is almost in a steady rate, means it is stabilized. So where a steady rate of aging is in motion. So when wear come across, you can say that the aging part of the mechanical component is started out, means you can not rely on that mechanical component to get an assurance that all the readings what you're getting or the output will be efficiently reliable, because it has started wearing. That shows that the material is now aging. So this wear come across when you are using this mechanical component for a continuous period of time, either through sliding or rolling. So the wearing phenomena also shoots a question about the age of the mechanical component, because you have to justify here every component is having its own life cycle, right? So in the initially it won't start aging. So when it is used continuously for a longer period of time, so it results towards the end of the cycle when it drops down from the reliability aspect. So this reliability aspect of a particular mechanical component reduces due to the occurrence of wear. So occurrence of wear is a second name for the term aging. So this is how you have to differentiate the stage in wear from primary to that of secondary. And last one is the tertiary stage. So what happens here basically, the component is totally in failure. So it results in the formation of a rapid failure and it cannot be used no longer. So you say it is like an example of old age. So once the old age, even though if it is of your own parents, you will put into the old age, saying that it is old age, or it's of no use for us. Okay, that is wrong on case of a human mankind. But when it comes to a machine component, it is totally a scrap. So we can say that the machine now is totally an failure, which is due to high rate of wearing. So high rate of wearing and high rate of aging is one and the same. Always the aging in with respect to mechanical components speaks with respect to our wear phenomena. So these are the stages of wear which come across. So you should be very clear to see that the wear doesn't come in any mechanical component. If it comes also when it is in primary stage, you should be able to recover, or else you cannot rely on this for a longer period of time to see that you will get the efficient results with respect to its reliability. So you have seen now the stages of wear. Why does this type of wear comes into picture is due to various type of occurrence. So first is called as the abrasive wear. The second is called the surface fatigue. The third is the fretting wear, and the fourth is the erosive wear. So these are the four major areas in which the wear comes into. So in order to understand why it is coming, how to prevent, you have to know some analysis, which is nothing but called as our wear analysis. So everything, you know that something bad happens. If you want to overcome that bad thing to happen, you should put a protocol like prevention aspects, norms, or your rules, so that you will be not facing that particular problem which can come into while using any component. So that is nothing but some amount of analysis is needed. Similarly, here a wear analysis is essential. So this wear analysis help in preventing the different type of wear which can come across in any mechanical component. So the first part of your syllabus speaks about the wear, the concept and its mechanism. So this is nothing but understanding the concept of wear, why it occurs, how the wear analysis is being done. So this all will be dealt in our wear analysis. So what do you do exactly in wear analysis? So it will analyze a given wear problem. Suppose in a machine the wear is coming into picture continuously even after taking all precautions. Then the person has to know exactly where the problem is. And hence there is a need for analyzing the wear problem in that particular machine, why it is occurring frequently. So first you have to determine and identify where the problem is. So once you identify, then you have to do the required analysis. So where you cannot observe through your normal human eye. So it needs a microscopic characterization technique. What I explained you already in a particular case study related to the Tribo system, which has been used in many industries. So similar type of analysis is needed here. So which helps you to show the clear picture of the worn area, how it looks like, okay, and how it could be overcome by using particular lubricant. If you're not using a lubricant, if the wear is coming into picture, then it is understood that you should go with some lubricant film, or you should see that the material what you're using should adhere or should have an adhesion behavior between two mechanical components. And okay, this is a case where you're not using the lubricant. If you're using the lubricant but still this problem persists, then you should identify which is the class and grade of lubricant film you're using. What is the thickness of the lubricant film you're using? Whether the thickness of the lubricant film has to be enhanced or not, depending upon the level of continuous rolling or sliding across the two mechanical components. So this has to be understood, right? So when you do this analysis, generally the wear will be always proportional to the applied load and the amount of sliding. Suppose if when you observe for any wear problem, there is no wear problem at all. The machine is good and it is operating well. And you analyze at the microscopic level and you see that the one which has been coming across is not due to the quality of lubricant what you are using. And the last phenomena which might be the reason is the amount of load what you are applying at the contact area, right? So mainly this friction and wear come across due to the amount of pressure which is there across the contact area. So it depends upon the area of the contact across the mechanical components and also the amount of load applied. In that stage, you should analyze the amount of load applied, whether it has to be reduced if it is not able to bear enough. So this is the third concept in which the analysis has to be done. Even if that is not, if even that is working well and there is no drastic change of effect across the mechanical component due to loading, then only the last option in which the wear is coming across is due to the amount of sliding. Sometimes the sliding distance might be less, sometimes the sliding distance might be more, right? If the sliding distance is more with respect to large speed unit, so then that might be the reason for a longer wear across a contact area. So then you should think about reducing the amount of sliding motion if you need the sliding motion for a very long period of time. So this can help you in overcoming the wear which is developed across the contact area. So these are the three fundas or the three thumb rule in which you have to do the wear analysis to identify why the wear is coming in frequently. If you won't do the analysis properly, then you cannot end up with a proper solution. So these are the three ways in which the wear analysis to be done. So once you're clear with this, so all these are exactly mapping with the case study what I have given to you. So I just request you humbly to go through that case study very neatly. Okay, so the wear analysis is usually done across the different type of wears which are usually coming in picture. So one first main thing is the adhesive wear. The second is the abrasive type of wear, erosion, polishing wear, across the contact if it is fatigue, and even the corrosiveness is considered to be as an wear only, and hence we call this as corrosive type of wear. And then electrocorrosive wear, fretting wear, electrical discharge wear, and the cavitation part, what we were discussing yesterday, even the cavitation damage is related to our wear. What you have understood and studied already in your fluid power system related to various hydraulic turbines. And last one is a false brinelling. So these are the type of wear which can come across depending upon which type of application you are using and which type of motion is there across the contact of the mechanical components. So now we are starting up with the first one, which is the adhesive wear. So adhesive wear come across when you have a removal of material due to the adhesion between the surface. So this theory, so this wear usually creeps into related to the adhesion theory what we have dealt already. So what happens here is the material what you are using might be having a good adhesiveness between the two mechanical components. Some might be having a mild adhesion. Some might be having a very good, severe adhesion. So when it has a good amount of adhesion between the contacting surface, so then getting the required sliding or rolling motion will be little bit difficult because there will be more adhesion to it. So while removing some, so while sliding between a good adhesion, it results or yield in removal of some surface films. Okay, so if both the mechanical components have very mild adhesion, then it usually results in removal of a minor surface films such as oxides at a very low rate. You know that mechanical components will be made up of different materials and it will be of different metal oxides, non-metal oxides, or it could be combination of metal oxide alloys. I told you when discussing related to friction, it can come across the metallic components, across non-metallic components also. If it is metallic components, then the bonding is through metallic bonding. If it is of non-metallic components, then it can be due to the covalent or the ionic bonding. Even in both the cases, you'll be having the oxides at the surface. So this will result in removing a small surface films of our oxides, but it will not be removed at a faster rate in a small amount of low rate. So this is associated with the mild adhesion. Similarly, next is our severe adhesion. So here the bonding will be too strong enough between the two material what you are using. That happens sometimes when you have the same kind of physical properties and you're using either same, both are of hard materials, soft materials, whatever, such that it has this adhesion against each other to a very strong extent. In that case, it results in heavy removal of the metal due to tearing, breaking, or even the melting part across the junctions. So this will result in a severe damage to the components across the contact area, and as a result it may result scuffling, or it is also called as a galling on the surface. Okay, so you can see these are the gallings or the scuffling which come across, right? So this is just an image to understand you the material transfer which takes place from one material to the other, because you'll be having two mechanical components across the contact area. The adhesion will be very strong enough, so when it slides roll, what happens is it results in the formation of some junction growth. So due to this, it results in the variation of either scuffing, galling, due to the movement of the material with a strong adhesion across each other. So now this is a thing which has been coming into picture due to adhesiveness between the two material components. So when you know that these are the problems which are coming on, you should be able to understand how it can be prevented. So to prevent, you should do a proper wear analysis as I showed you before. So the wear analysis, again, it depends on the three clause, what I have explained you already, right? So you have to see how it could be prevented. So the adhesive wear could be prevented, right? What you have to do with respect to mechanical aspect and with respect to the lubricant. So with respect to the mechanical aspect, you have to see that you reduce the load which is being subjected across the contact area, and also the speed with which it is sliding. If you have subjected that mechanical component to an high temperature, then you have to see that even the temperature associated with the mechanical component should be reduced to some extent. So this is the first mechanical aspect what one has to think as a tribologist. And second one is try to improve the oil cooling. Okay, so sometimes you need the proper oil, your lubricant to run your slide. And you should also see that the coolant is needed to make the oil which has been used is at normal, yeah, below normal temperature. And third one, you have to check the compatible metals. You mean to say you will select the material. See, selection of material in everything plays a vital role. You have to select the metals which are compatible with each other. If the metals what you have selected is not compatible with each other, again it results in the formation of wear. So you have to think about the metals what you have selected, whether it is compatible or not. And lastly, you should apply some coatings across the contact area. Usually the coatings which are applied is related to the phosphate and its dopants. Okay, so application of phosphate with its dopants can also cause a coating area, so that even though if these problems come across, this coating area will overcome in all these wear fundas, and the mechanical component can run very smoothly with reduced amount of wear. So these are the precautions what you have to use with respect to our mechanical perspective. So apart from that, you have to think about the lubricant also what you are using, because you have to use the concept of lubricant what you have studied already in the previous semester, and currently also you have dealt about it in our first module. So what you have to do is you have to use more viscous oil. So the lubricant what you're selecting should be of having a high grade of viscous in it, so that it helps in separating the two surface. Means to say it helps in formation of a thick film of the lubricant, and hence it is well separated. Even though if you don't use a coating, if you use a high viscous lubricant in this type of condition, it really helps to separate the surface. So even if the wear come across, it won't result in the formation of this gulfs, yeah, scuffling. Okay, it could be overcome at the mild adhesion level, right? If severe adhesion comes into picture, then it will be leading to a scrap of the component you cannot use for further time. So this is the first aspect. Second is you have to use extreme pressured additives such as sulfur phosphorus, yeah, borate components. So this helps us to use as an anti-scuffing agent. I told you that scuffing come across due to severe adhesion. If this has to be prevented, the second methodology what we can follow is you can use some components as an additives. So which is the most commonly additive suitable to overcome the scuffing is nothing but the sulfur phosphorus or the borate compounds. So this compounds, if it has been mixed and applied across the surface of contact area, so this will help in overcoming the scuffing part which come across in severe adhesion. Okay, so this is about our adhesive wear and how it can be prevented with respect to our mechanical perspective, and as well as selecting the grade of lubricant and additives in it. Or else you can apply some additives to the lubricant film. Even this is possible. People are trying in two aspects, to apply a specific coating across the surface or to embed the lubricant with respect to this type of additives. In both the case, it works out smoothly. It depends upon the application wherein you are using, basically, and for the time period also, to how duration you are applying for the sliding or rolling motion. So this is about the adhesive wear. Is this clear? Hello?
Yes, ma'am.
Yeah. So next we will be going for our abrasive wear. So abrasive wear is again another type of wear which usually comes in. So what happens here? So sometimes you might be having a very soft surface and a hard surface. So when you have a combination of soft and a hard surface, this usually results in the formation of an abrasive wear. Okay, so here what happens in case of abrasive wear is the cutting of the furrows on a surface by hard particles. Means it is nothing but one end will be having the hard surface, means the asperities, what it is there across the surface will be very sharp, and it results in cutting the furrows is nothing but a very minute amount of materials which are removed like an scar. So you have operated in the lathe machine. So when you operate in a lathe machine for either turning or any type of operation, the materials are removed in a minute chips, sometimes continuously or sometimes in the form of powder. So even the sharp asperities which are there across the surface can result in cutting some of the material from the soft surface. So this again results in the formation of wear. So this type of wear is nothing but our abrasive wear. And mainly it can be reduced by using the hard coatings. Since the material at the other end is soft, if you have to overcome this type of wear, you should apply a particular coating along the contact surface of the soft surface so that it will able to withstand the rough asperities which are there across the hard surface. Right? So this will overcome in removing the abrasive wear. So this can happen in case of two body abrasions or in case of three body abrasions. Okay, sometimes you might be having like a three body abrasion. In between you have a very hard abrasive material as a component in between hard and soft. In that type also the abrasive wear comes into. Without the third body, even though when you have two bodies at contact, then also if it is one of soft and hard, the asperities from the hard surface will help in removing the material in the form of minute scars. So this again results in abrasive wear. Okay, this has come out twice. So abrasive wear again can be overcome with respect to the two perspective. One is with respect to mechanical, another one is with respect to the lubricant. So what do you do over here? First thing I've told you that we have to use a better hard coating material that we have discussed already. So apart from that, you should see that remove abrasive by improved air and oil filtering, clean oil handling practices, improved seals, flushing and frequent oil change. So if you follow these protocols, you can see that even the surface of the hard material will be almost smooth enough without any asperities across the surface. Asperities are nothing but the sharp edges. So if you don't have these sharp edges across the hard materials, obviously it won't result in the formation of wear across our soft materials. So you have to see that the oil what you're using is being changed frequently, because sometimes even some scrap, if it mixed with the oil and if it persists on the surface of the hard surface, then that can result in formation of the wear in the soft material. So, and it has to be clean. The surface has to be cleaned thoroughly always. And if you maintain a proper cleaning practices, okay, all these things will help in non-formation of the hard surface, asperities across the hard surface. And second one is you should always see that you minimize the amount of peening, the beading, your sandblasting of surfaces, because abrasive cannot be completely removed. So what is the second thing? This all comes into picture when you're using a hard surface to make a mechanical component. So if the operations are not performed well and the surface is not finished, right, it might result in some peening. Yeah, peening is nothing but the extra surfaces which are there across the surface. So if you visualize the surface, by visualizing through our human eye, you can see that the surface is good enough. But when you touch, you can feel that some abrasions are there. Okay, so these are nothing but the rough surfaces. So these rough surfaces, when you observe through a microscope, you can understand. So what are the surface roughness level you are getting? That could be identified by the topography measurements also. And thirdly, the option is to increase the hardness of the metal surface. Means the soft material what you are using, the hardness of that soft material has to be improved. So only the option is you have to use some hard coating which has a proper adhesion to that of the soft surface, so that the hardness across the contact area will be increased. So if you do that also, it helps in overcoming the abrasive wear. So these are the three options what you have to consider with our mechanical perspective. So the next one is a part of lubricant what you have to understand. So here what we'll be doing is you will use the oil free of abrasive particles. So the oil what you're using should be free enough from the abrasive particles. It depends upon the grade of oil what you're using. You have to check about the freeness of the abrasive particle in the oil. If it is so, it will surely help you to remove the concept of abrasive wear across a contact area to 50 to 60%. And second option here is also again you have to use more viscous oil. So this is about the abrasive wear prevention. So last one is erosion wear. So I'll just explain this. Okay, so erosive wear is mainly due to the amount of furrows on a surface which come across. But it is 9:26 already. I hope you have a next class. I will complete this part in the Saturday's class. Okay, so this portion will be there for your internals related to the wear mechanism. We have to deal with like around three more, roughly around 5 to 6 types of wears. So that I'll do it in the Saturday's class. So now I'll currently stop in. After the class, I will be sharing a quiz. You see that you attend the quiz during your tea break. So now, if you have any doubts, you can ask, or else I will take the attendance. In the meantime, you can type your name and USN number in the chat room also. Today is 1st October. Please don't miss any classes. I'm telling you on and on. Abdul?
Yes, ma'am. Present, ma'am.
Yeah. Akhil KV? Akhil KV? Absent. Anil Kumar?
Yes, ma'am.
Yeah. Ankesh Aman?
Yes, ma'am.
Gautam Krishna?
Yes, ma'am.
Balaji VR? Absent. Beldar Mohammed?
Present, ma'am.
Chaitanya?
Present, ma'am.
Chetan Kumar?
Present, ma'am.
Dheeraj?
Present, ma'am.
Ishant? Okay. Harshit S?
Present, ma'am.
Himanka? Himanka is absent. Kanishka Reddy? Kanishka Reddy is absent. Nagamurli Krishna? Okay. Kunal Raj? Okay. Danush? Danush is absent. Mohammad Ayan? Mohammad Ayan? Mohammad Junaid? Mohammad Junaid? Are you present? Absent. Shri Prasad?
Yes, ma'am.
Okay. Niharika?
Yes, ma'am.
Nihar Venkat Sai?
Yes, ma'am.
Nikhilar? Nikhilar? Absent. Nirab?
Yes, ma'am.
Prajwal S. Bhatt? Absent. Rishabh Pandey?
Present, ma'am.
Rohan? Rohan 17ME042. Roshan Yadav?
Present, ma'am.
Yeah. Sumant Sagar? Sumant Sagar? Okay. Absent. Sagar Dutt Mathur? Absent. Sagar GV?
Present, ma'am.
Sanjay Raghav,
Present, ma'am.
Shobit,
Present, ma'am.
Siddharth B, Siddharth B, absent. Siddharth Sridhar, absent. Subramanya, Subramanya, okay. Tirumani Seti Rohan,
Yes, ma'am.
Ulas, Ulas you, absent. Vidyan, Vidyan, Varun, Varun, Pavan,
Present, ma'am.
Danush, Danush, absent. Dhyanesh Kumar, Dhyanesh, Gunasagar, Gunasagar, Meghanatha Prasad,
Present, ma'am.
Ma'am, Gunasagar is present.
Gunasagar is present. Okay. Meghnath,
Present, ma'am.
okay. Rasik Baran,
Present, ma'am.
Shiv Krishna, Shiv Krishna is absent. Shreyas, Shreyas is also absent. Srinivasalu, absent. Yogananda,
Present, ma'am.
okay. Kiran R, Kiran R, absent. Shiv Pavan,
Present, ma'am.
okay. Gautam Sai,
Present, ma'am.
okay. Anyone whose name I haven't called out?
Ma'am, 33.
You are telling about your USN number? Nikhil R. Okay, where were you when I called?
Ma'am, couldn't switch on the mic.
Okay, fine. So see that you people do study well. I will just share the PPT of module 2 as well, where module 1 is shared, and also some of the material related to module 1 and 2 also I'll be just sharing related to your IA portion. Okay, so please do your groundwork, study properly and do well in your internals, which starts from 5th. So on Saturday's class, I will be completing the remaining type of wear mechanism, how to analyze and prevent. So until then of Saturday portion, you'll be having for your internals. So I hope everyone have written your name and USN in the chat room. If anyone have not written, kindly do type it out. Okay then, everyone, please take care. Have a nice day. Meet you all again on Saturday.
Thank you, ma'am.
Yeah, thank you. Bye-bye.